For class example 1.11, we'll be determining the domain and range of functions given their graphs. I highly encourage you to pause the lesson at this point and try examples A through F on your own first. Here, we're asked to determine the domain and range for each function, and to write each of these in both set and interval notation. Let's start with example A. We'll first work on domain by identifying the leftmost and rightmost value of the graph. Here we see that at the leftmost point, the graph goes to -4, and the rightmost, it goes to +4. Students will sometimes ask, how can I tell if a value is included or excluded? If you see a hollow circle, that means it is excluded. In all other cases, you should assume that the point is included. For the range, we identify the lowest height of the graph as being 0 and the highest as being 5. Note in both instances of set notation, we specify that x or y is an element of the real numbers. As we determine the domain for example B, we see that to the left end we have an arrow, meaning we go on to -infinity, and the right end point stops at an x value of 4. So in set notation, we will say that x is less than or equal to 4, and is an element of the real numbers. In interval notation, this involves putting a rounded bracket on -infinity as our minimum value, and then a hard bracket or square bracket on the 4 as our included maximum value. When considering the range here, typically we would say that y is greater than or equal to -1. So in set notation, it is completely appropriate to write it in this way. But you may feel more comfortable writing the minimum value on the left. So we could also say that -1 is less than or equal to y. We may in fact even read this as y being greater than or equal to -1, but could still write it this way. This is helpful if you want your set notation and your interval notation to correspond more directly. We see that on the interval notation, we are obligated to write the -1 on the left because it is the minimum value. To write +infinity, -1 would be an error. Example C has no restrictions on its domain. So in interval notation, we will say from -infinity to +infinity. In set notation, we will simply state that x is an element of the real numbers. Its range is also unlimited, and so we use the same notation. Example D doesn't offer much new in the way of domain, but has a very important discussion when it comes to its range. We'll see here that the graph seems to be leveling out at a height of -2, but the graph has a dotted horizontal line at -2. This is called a horizontal asymptote. You may remember me saying earlier that a horizontal asymptote represents a value that the function tends toward but does not reach. If we understand the nature of horizontal asymptotes, we will understand that this implies that y will not reach the height of -2. If it did, there would be no reason to draw the horizontal asymptote. So here, our range will be y is greater than, but not including, -2. And so in the interval notation, we'll be forced to use a round bracket. Example E is a graph of discrete data. Here we are not able to use interval notation because it is not continuous. We simply list all the x values for the domain and we list all the y values for the range. If a value is repeated, such as the height of 4 in this example, we will not list it repeatedly. only once. Example F is another example where the domain is unlimited, but the range has a lowest point. Here we see that the lowest point of this graph is at a height of -5. So our range will be y is greater than or equal to -5 and is an element of the real numbers. In interval notation, we write this as square bracket -5, comma, positive infinity, round bracket. Hopefully, those 6 examples give you a good overview of the kinds of graphs you might see and for which you'd have to determine the domain and range.